let's now start off. And so given an assignment, I don't know if anyone has tried to do the assignment. Let me know if by from the response chat, or you can just do a thumb. Anyone who text in the chat if anyone has been able to do the assignment. Look at it. So I hope everyone saw the assignment. I'm not seeing any responses. I assume silence means no one looked at the assignment. Okay, I see Leila is saying she tried, but she could not complete. Anybody else will give it a try? And maybe for Leila, what was your progress? Where did you find a challenge? To identify the required task.
So I put timers and then okay, let me just go there. I put timers and then, like, let's say for the first light for stop, like I put a timer. I put a timer as normally closed, and then okay, let me just I don't know how to explain.
You did it in the software.
Yeah.
Are you using your machine?
Yes.
You can just take a screenshot and share on the chat. You paste it on the chat. I can see what you did. And then from there I can try and see what. You know how to do that?
I don't know how to take a screenshot with my laptop.
Okay, just type on Windows, press the Windows tab and then type sniping. You'll see sniping tool. Type sniping, just type the word presidents, you see sniping tool. Seen it?
No.
You press the Windows tab, it brings up a startup menu. Then you type sniping.
Oh, okay.
Sniping tool.
Oh yeah, I've seen it.
Yeah, now you just create a new, highlight the page, and then you take the area you want to, and then you go and copy. You copy, come and paste. Like, let me just do it on my end, new, and then I take a screenshot of this one. And I say copy, and I paste on the chat. Can't paste direct. Let me see. Notes. Okay, it is not accepting paste command. Let's see.
Okay.
Chris, open. Oh, Daniel, you know how to do paste on this Cisco WebEx meetings. Let me see, share file. I think it's open. will be X. This is 0. Pictures. Open and share. Share file. So you've seen how to share a file. Let me see if I'll be able to do it on my end as soon as possible.
Okay.
Go to pictures. So you've seen how to share this file, right?
Yeah.
Everyone can see the file, right? So I think you just do the same. You use the sniping tool and then you save. After you save, then check, copy the path. Then path you go and paste. And you go to file. You go to open and share. Then this is how you'll see it. Because that's what I want us to do now. And,
Okay.
so in the interim, let me share my screen as she looks for that file. So we can start off immediately. I hope all of you can see my screen. What I did is I'm going back to new file. So I'll go to the new file and I hope you know how a traffic light operates. So that's what we're going to do. So now that most of you did not attempt the question. So I'll do this, go to new, I select the PLC module which I have, and I go next. I don't need any input. Assistant for VDC. I go next. This is the programming language. I'm going to select FBD. So if you go back, you can say that if you select, this is the language is highlighted here is either FBD or LAD. So if you select LD, that is purely ladder logic. And if you select FBD or LD, that is FBD functional block diagram and ladder logic. So I'll go with the PLC that I have on my end, and I go next. I select FPD, because that's the language. Yesterday we did ladder logic. So today we are going to do FPD, and I go new, and the interface is different, as you can see. Right. So now we begin our programming. So we have, let's start off first. How many inputs do we need? For starters, you need Layla, can you share with me what you had in your end?
Okay, like the file.
No, because I think the file you haven't shared, so I need to know how you did it.
I just put a timer. You need like four lights: red, amber, green, and then yellow, and then yeah, and then red and amber, which is like the yellow. So I put a timer to count for the timer that I put for red is 14 seconds, and then I put that timer as anomaly closed in the next rank for like get ready to go after stop
Yes.
yellow now. So I put it as anomaly closed in the next rank, which is for red and amber. And then okay, let me just go there. Yeah, and then I put the second timer, which is now the timer that's going to check for how long the red and amber is going to be on, which is like 5 seconds because it's like less time. And then that timer, the second timer, which is anomaly closed, I put it as anomaly open in the next rank, which is for green. And then so that after the 5 seconds are over, it will close, and then it will activate timer 3, which is now the timer that's going to time for how long the green is going to be on, which is 14 seconds.
Okay.
And then the last rank, which is like for amber, and then the sequence continues, like goes back to the beginning and then inaendelea hivyo. Yeah.
All right. Okay. So that's a good effort. Thank you for that. Yeah, that's very good, and it's commendable effort. So I hope all of you understand how the traffic light sequence works. And what you have is, of course, you have three lights: red, yellow, and green. And how they always follow is, you start with red, go to amber, green, amber, red. So for red, you stop. Red and amber, you prepare to go. Yeah. Then you go to green, and then you go to amber, and then you go back to red. So that is the sequence. So for us, we need to have a start button or a start command, and we're going to do our naming. Yeah? So I'll select an input. Maybe that's a start. and then I can say it's like this. I can take another one. So at least now you have that one, and then you have the lights, which are this one. So we have the outs, we need 3 lights. We need that one. We need, in fact, we need 4 lights. 3, okay. So you check this one, yeah. So I've indicated this one. My queue is red, and then I'm putting a comment. Click on it, and then you come and insert a comment. Red, amber. I think that's a wrong spelling. Display the comment. And I can say this is red. I put red here, and I go to green. Right. You can start this one as, can comment this as my start. This thing. I put it as display comment, and then you put it as can change the way it is depending on how you want it to be, like a push button. This is my start, and then you need to have a reset. Set as yellow. I display the number. Sorry. So this is reset. So you can either try to hide, or this can do that, you hide, and then this is start, stop. So we need how many timers? We need timers. So the first timer is for the red light. Second timer is for amber. And then you have green. Okay. So firstly, let's have the timers. You got logic. So you can have this one. If you double click on the timer, you can see the parameters. And then you can put a comment, display the comment. You can say this is for red. Then the parameters, you can say maybe you should say 14 seconds. Right. Say these 10 seconds. Then unit is seconds. You put it 5 seconds here. You say okay. So this for the red one. And then, so at another point, you can just try and now you can either copy this CV and you change the naming and change the timings. Say 5 seconds, this is comment So that's how you comment your work. You need to label your work. You can just hide these ones if you want to not to see, and then you can bring this on here. And there you go. So you want this one to be so you go to the question exclamation mark. Let me show you what you do. If you go to the exclamation mark, it brings you a window which is help, and it tells you how the timer operates, like you can see. So what it means is that's the use of a help menu. It's very important if you're doing any program. The user manual is very important for you to understand. So the following is the output. So you can see the timing diagrams of this PLC. So you have your timing diagram. You have the input command, you have the output. And you can see how the input and the output command go. So you have on delay. It will delay after a certain time, then the output goes on. If you put the off delay, it will delay before it shuts down, then goes down. If you don't put the off delay, it will just, this line will not be there. Okay, so that's how you interpret these timing diagrams. Here you put high. So when the input is high and the on delay is active, now this is the time that now the on delay is already elapsed and your input is still high, activation input. So you have a high here. If you reset, if your reset button is high, that means it transitions from 0 to 1. The whole output goes to 0. What does this tell you? That resets in most cases is always, it takes precedence over enable, because we mean it's like an emergency stop. Okay, and you check on this other side. I'm just using the menu for that you can be able to understand. You have a Boolean equation here, and this is just a menu for you to understand. You see you have set reset function, so it tells you what so the menu means. You have preset up and down counter. It tells you, gives you even the timing diagrams, and you understand from either computer scientists or engineers or technologists. So you understand that when you look at a timing diagram like this one, you can be able to get what it means. So all these are blocks, that function blocks, that you can use them in your day-to-day programming of your controller. Okay, and that becomes very vital. It becomes very good for you to do this kind of, you use them. You also have your calculation is equals to input 1 plus input 2. You have multiplication, division. You can select the functions that you want. You also have, just it says, you can check the status of a block. CAM, this is just something else, bit to word. If you want to do a conversion, maybe you have binary to word or a word to binary, and then you want to get the outputs and extrapolate the outputs and use them in a different command. You have sunrise or whatever. Then you have application blocks. I just want to brush you through. These are other functions. Like you see, these are very complex. Looks beautiful, so these are some of the things you'll be doing on your end when you have such kind of things. You need to try out, go through this menu, try out these things and understand what they mean. You have the SFC, you have the hand off. Yeah, they look a bit, they're not complicated. If you try them, then you understand the functions. This is from the user manual. This is within the software itself. So it's up to you to try and get through the manual, do the practicals, this, yeah, and from there you'll be able to understand what they mean by that. Another thing is a PID representation. PID is just a function. I think for those who are doing engineering, they know about a PID. And where you have, maybe you want to set maybe the way the AC works, the air conditioning unit works, it uses a PNID control, where you have is you take your remote, you set a temperature, and then you see the AC controlling the temperature. It can either bring in cold air or warm air, or even if for a vehicle you have a vehicle AC and it's on, and you'll see that it will try to maintain, it will compare the outside temperature but maintain the inside temperature. That's what it's important for it. So it will take the outside temperature. If it's hot, it brings in. If the temperature is not hot, it will ensure that the compressor is on. And what the compressor will do, it will check heat from the engine and compress the heat. And once you compress air, if you compress air, heat generates. So that's what the AC, the compressor of the vehicle does. It will just take air, heat, compress it, and then you get heat. So you're able to get the heat from the AC of your vehicle. Of course, it uses fuel, so you need to have fuel for you to use the compressor. And so that's just a simple application of a PNID. So that's how it is used. And the PID function, you can now set your variables here. Of course, there are standard variables like this one: pressure level, temperature, pressure. These are the standard variables you need to put in the PID controller. So you see you have KP, TI, TD. You have the PWM, and this is the period upon which you're going to vary the speed of the compressor. So this way you have all of them, and you just need to apply and use them as you wish. You have the guidebook, which will be able to give you what you're supposed to do. So I'll close this window and we proceed from where we were. So you have 5 minutes, 5 seconds. And then you can have a start. This start button is to start everything, to activate everything. Okay. So all these are reset. So if I want to reset timer 1, how many timers? 1, 2, 3. Maybe I want to use this one as a stop, and then I use a third input as a reset. Take this one and I'll use it as reset. I can now edit. A menu which is open. This one. It's another menu which is still open. Which one is it? Check. Get back to it later. Mr. Screen. So this is our start. This is our reset. And this reset, we're going to wire it to each of the PLC, each of the timer. Okay. So we wire each reset to each of the timer. Take it there, and this one, take it there. So you need to be organized when you're doing your PLC programming. Very important. You miss out anything. So for your case, now you have an emergency stop. That is a stop. You want to stop the sequencing of the lights. So you have to use something anomaly closed. So how do you form anomaly closed in an FBD? You form it, you pick an AND gate. You go and get an AND gate from the logic, an AND gate which is here. Okay. In this AND gate, the conditions are for any of the timers to begin, the input should be high, and for you to stop the process, you can either decide you take a note, you note the input, take a note, you put it there. That is how you approach the logic, because you want it to be normally closed. The system should work. If you press, then it will disconnect. That is the input. So you AND this input and then you bring it here. So this is like your timing, and then we're doing small progress. So see, it's already on, the timer is already on. So if I press this one and I run, the timer will be active. Okay, it changes state from on to on. So if I press this one, off. Yeah, but initially it's off. Yeah, that's how you do some small programming. So in PLC, it's advisable you do incremental stages of PLC programming. If you do vast changes, you can do versions. The same way you do JIT version, do it the same way in the PLC. And you're able to get progress. Small progress is important in programming PLCs. If you do big, you might end up maybe messing up a program. So like this one is working. And this is the reset. So for a start, I want my program to start. So what I'm going to do is I press this one to start, then the PLC will, the timers will begin running. So let's see how it will work, and then we are going to edit. So I'm just going to do quick wiring, this one here, going to the command, then just a quick one, and then you can see what I mean, and then you can see it on the fly. Okay, so there you are, and this guy can come down. So it come uniform. You see, you need to make your work look beautiful. Then we can run simulation, and then you can do small simulation if you're not sure. And you can start to see the timers are running, and then you switch the output on. So I think all of them have been set to 5 seconds. Let's see if we stop, we edit, and then you connect this one to the output. 1, then goes to output 2, then goes to output 3. And then you can have, these are values. If you check here, on delay set point, this is on delay current time, off delay set point, on delay. So we take the current time. So there's something you pick. This is called, you can take a display, but display will give you many items. Take something called a text. Yeah. So the text needs an active signal set. So I pick a text, I basically give it an active signal. And I might try and see if I can make. I get the active time of this input on current time here. Remember, this will be seen only on see the active see delay current time. Get the second variable on delay, third variable. So in your PLC, if you have this is the screen, so it will show you if the screen is something that is occurring. Screen, some command is out, some just to program. So later. So we have three outputs. And from there we have this text here. So now we can change the value. Let me just try and close. Let me save first. Close this program again. It's coming up. I'm gonna need this thing to simply zero. Screen disappearing. See, right. So this is how you're able to check. So if you look at this window, you have, because for the first line you have a date and time, 6 a.m. 1, 2, 3. Okay, you can try and do something. So you can drag this value here and say you want on delay, so you can now type something that is red. This is green. Okay, and you have so you can either do on delay current time delay that is, so you can have this one. Then you can drag, you can say traffic light control system. And then you drag this one, so it's for red. Okay, the automatic modification. The systems will be able to modify them. start, it starts from 0. So let's see, if you stop before the value is, let's see what happens. You start for the first time to come. So if now we stop, you see the values have gone back to 0. But these are the preset values. Okay. So again, you start again. Just something else. Just for the on time, just something on the PLC. Yes, if you have a 0 of 10 volts, this one can see how the voltage is. So now everything is up and running. So you can do slight modification now. Those lights are not okay. We're just doing a test. You want that before timer elapse. After timer 1 goes on, so it needs to run for this time. Stop. This one was using an off delay. Time to come. Okay. Now, for that case, for your circuit, right? How are we going to do it? Let's modify it and see what happens. So you might slightly change the program. In fact, you might change the program. So you want that when this timer is on, this light to come on. So you need now we need to employ logic gates. Logic gates will have to be employed. And now it's up to you to decide how you're going to do the logic gates. Okay. So let's say you have this one. Remove the signal. So you want that. Let me put this reset here. Just put them. This reset switches. Down. So turn it where it was. Yeah, it's better. So you want that. And this timer is running, and 14 seconds have not elapsed. The output should be okay. So how we do it? You know, expand this one, take these guys out. So you have here, you have to implement some logics, things to work. They can't work like that. So we're going to remove the outputs. So you need that. You want to make a logic that start timer 1 B005. Before it's done, the LED should be, the red should be on. So you need an AND gate to perform that operation. And how is the AND gate going to be incorporated in circuit? You're now going to call an AND gate and program it. That before the timer is done, I should not go to next step. So this guy can go up, up, up. This guy can just remain there. And now you need to call an AND gate. So you go to the logics, call an AND gate. That before this timer is done, we are counting down 14 seconds. Then we need to the output high. It's over. We go to that. So when the timer is done, before the timer is done, check the input here. So logics are very good. If you could have shared with them, it'd be very nice. So I'm doing it because so we get the not get to get and not get to enter that. Before the timer is done, the output is on. Okay, so that here get a note that before my timer count, output should be high. Okay, and when the timer is done, I check this input, go to the next step. Okay, so I pick this input. So I want it to count before. So immediately I start the circuit. This should be on. Okay. So it counts for 14 seconds. And then when this is done, it shifts the logic. So I pick this logic here. I transfer to the next gate. So this is like a staircase. It's cascading. I pick this one, cascade on this next one. Cascade it here. So you have this one. When this is done, take output here. But before it's done, output there. Okay. And remember, when this is now, this light has to go on. This light has to go off. Okay. So this light has to go off when this timer is running. So you need to find a logic there. That my LED should be off. T2 on. 2T is engaged. That timer should be. So when this timer is done, okay. So you want that. We're going to remove that logic. So you do for one circuit and see how it operates. And before this timer is done, output to be high. And for this is done, this guy here. Okay. So before this guy is done, take it there again. This timer is done, take it there. So take another tick here. And put it here. Let me do this. Just help you understand better. And I remove this one to avoid crisscrossing. This. And I do this for you to be easily see. Put this one guy here. So I want that. Before the timer elapses, and so check on the logic. So you want that before the timer elapses, and the timer has been set to on. So you need a start command. So before the timer elapses and this is on, and this input is not active, so this input process. The timer, this light will go off and I transit to the next time. So let's do it fast. And you will see what I'm talking about. So let's just simulate once. It's already active when I press the start button. Okay, so this is already on. Now the PLC is not running, so we take care of that. We first need to activate the running. See, so the input will start counting, and we need a start signal. So the start signal will stop, edit, is to come to this point. Yeah. Okay. Simulation, and then we start. It counts. The light is on. After 10 seconds, it will go off and then start running this second time. It's off. Right? So this is the first implementation. So we start, stop, we edit. Now we use the same logic here. So you want that after this PLC is done and this timer not done, you take it again. So we take copy paste and copy paste, copying to the 3 bytes. Then any modification you do to check, and we can just be able to use our logic. Okay. Yeah, so to that, the same input here. Before this input is done, the light is on. And for you to activate this next sequence, this one, this PLC, this logic here must be off. Okay, see how I'm going to do. I'm picking this guy, I'm picking this signal here, sorry, and I'm taking it here because the signal is done. That timer now has completed the cycle, goes on to the next one, and then this cycle, because this PLC has completed the cycle, activate this block. Okay, and you take this block here, right there. Okay, so this timer has completed cycle, turn on the sequence. Now this one has not completed the cycle, turn on the lights, and then this one should be able to activate the next output. This one should be able to activate the next output. This meeting is so we just changed to maybe 10 seconds. It is much easier for us. You can just see it faster. 10 seconds again. Turn that different values 10. Change everything to 10 seconds each. Demo, you can change what you want. Find time. So you can see the preset time should be 10 for each. Okay. So let's run the PLC program again. See the logic that it executes. And then you can make it. So we go to simulation again to put it on. So we have to reset everything. Yeah, so there's a signal that is missing here. There's a problem here. So you need to debug your problem. If the problem, just debug it immediately. So what the signal is missing is this signal. Should tell this one start and done. The guy that was missing there. Good. Yeah, I just want you to see how the signals are going, so that you can be able to understand them well. So when this is done, First light is on. Then so you see, so there's something that the logic did not get. Yeah. So we stop again, we debug, check this is signal that is wrong. Yeah. So this one done should not come from here. The signal should come from this guy here. Because it's associated with that one. So now it should run. So sometimes you need to debug your program. So you see, you need to set stepwise and you can save as versions if you're dealing with a big PLC complex program. And you can start. So let's wait for the first 10 minutes. You can see the value here changing. And the value, the first value is changing. 7, 8, 9, 10. You see the next LED is on Q2. Okay. Wait for the next 10. The LED is off. The next 10 seconds. Done. And everything is off. Now you can now start, can reset. Okay. And release. And start again. So you've seen the reset is working, start is working. The emergency stop should be able to reset. It only resets the values, but you need to have one that is able to stop every light. So this one is just to reset the counters. This one is the one that is able to stop every process. Okay, so that's why you see it begins with the start signal. So the next step is we need now to have an automatic sequence. Okay. And at some point you need to have the amber and the red to come at the same time. That's something you'll implement later. If time allows, you'll implement it. But I do it as an assignment and you can be reviewed it. So I can stop the simulation. And I want to implement that when this sequence is done, you need to reset. You need to reset that controller. So there are so many timers that are here. So you can go and pick. Take a pulse timer. And you can just check. So you can decide to use this function here. So the thing we called pulse, these are what we call pulsing. They're called pulsing release. And the command help says creates a pulse on the output using H. Processing of the command. So you have your input here, a discrete command input, a discrete reset input. So the output is digital time, and then you have your time and everything. So you have a pulse. The command goes down, then pulse command goes down. So you can try the function before you even implement it. You can have another input here. You have to test this function. Sometimes most of the time you'll be referring to the user manual because every PLC comes with an embedded user manual. So it's very important to actually understand so you can decide and say you can put in a value one to the functions. You need a value, say a number, and you can put 1 second here. Double click on it and edit the parameters, and we see what does this output mean. You can even get to an so you want to see what happens on key 4. Let's test this function, simulate. So you can read the manual and it gives you an so check on key 4. Okay, so when the input was there, so as long as there was a pulse, okay, yeah. So now this is the function we're going to use to reset. You set here 1 second, and then you able to do it. So let's go back to editing mode, and now this input we remove them because we already know what the function does. So this is for setting, of course. You can maintain that, and then you can remove the signal, and you can bring this function because yeah. Now this function, what you want it to do is be able to, instead of putting on key 4, should be able to tell it to activate or reset the timers. So how we're going to implement it is what I'm going to do. So I take it here. This is where the value belongs. And I want to activate it when this last block is active, when the last timer is out. I take it here. I command below to activate this timer, and this should be able to reset all the counters, these reset timers. So I pick, instead of picking them, I pick them from here. Okay, so I'm going to pick this. This is my reset. Again, reset. Again, reset. And you can in one single way. Now, let's see what will happen. We do simulation again. So we are modifying the circuit only by if you maybe just save as a version 1, version 1.0 as you progress, because you never know. It's a PLC program now. It's changing. As it changes, it becomes more complex, more complex. Now you see we started with 1 block, many block do you have now? So by the end of the day, you have a lot of blocks, and you cannot trace your path backwards. Hey, my friend, you can know even possible. So it's better for you if you're saving something, save as a version 1.0 until you now, so that you can trace back the last one that worked well. You can pick that one, check where the problem was, and you can be able to modify. In advanced PLCs, you can save them as versions and you can do comparison. You will check to tell you which block changed and how it changed. So for this one, so these ones we have this, and we can now start the logic. And we start activate, and then we put a run PLC to run. So want to see what will happen. So here we have this block is auto sequencing. It should be able to automatically reset the blocks and make the system autonomous. When all the time is elapsed, all the LEDs are out, we should be able to reset and go back again. Alright, so let's see what happens. Good. So I think you've now seen how the system has been able to reset, and now the system will run endless. So it will have an endless loop because it will be activated. And if you have this guy here, if you had this PLC, you could be able to see the output here, to see the outputs running up and down, and how we edited the PLC. Okay. So if you had maybe like this one, if you had the real PLC, you could see the time counting, and maybe you can something of the sort. Yeah. So you see that, so it's now automatic. So this is how the lights, the traffic light sequence is done, and majorly it's done by PLCs. So industrials, they're really extreme, so they can work in any harsh conditions. So this is just a simple program. It may look like a very simple program, but it is not. You have to use some logic, you have to think. So all these are instructions you have to write and analyze before you put them. Because one thing you need to know is if you work with a PLC program without a logic, it's a waste of time because you will find so many errors. You have to debug. Then once you've debugged, paper now go to the PLC and start your programming cycle. So that's the best way of programming. Otherwise, you program in a PLC and you simulate, you wait for the output, because the PLC is just getting what you want. So best way is first approach it. You have to see. You have to run the PLC from you run the PLC from screen. You have to first write the logic, write the statements, then analyze the statements. Once you've analyzed, put them on the computer, and then from there you can program it and then simulate. Once you've simulated this now, you can now upload it to the PLC and everything will be fine. Don't have any problem at all. And so this is just one simple program. There are so many other programs that you guys are going to share. The guide that I told you, but this is how you do function block. So there's one thing that is remaining to enable. How do you make that block the red and amber come on at the same time, right? So you need the amber and the red to come on at the same time. Okay. And then from there it should now also be able to go off. So let's see how that can work. You have to think again, sit down, draw a logic circuit. So how we're going to do it, let's think. Say that Yeah, so for me, I'm doing it because I understand this, but it's very important. You got gigs. I'm well, to me, I'm just doing it from the head because I used to this. For you, you have to write logics, otherwise things may become messy, and you have no to use in the field. Given the assignment alone, it's there to help you. So you need to analyze your logics. So what I'm doing, I want to get a value, and this value is defined. I want this timer to come at a predefined value. So how do I achieve that? There are this on set to on, and I told you these are just blocks. And if you want to get, click the question mark, and you get what it means. So an integer value, this is a function block. So the set allows analog value to be monitored relative to thresholds. Changes if an input value is less than maximum value, minimum value, and the input value is greater than maximum value. If the input is between the two, the output does not change state. So each of the form to off and from on to off can be set as maximum or minimum value. And you have an enable function. This is how you get the timing diagram. And you need to be very analyzing these timing diagrams. You know, if the input is this is a value that is rising to comparison. If it's changing from off to on, and this value on to off is bigger, we have and so if this off to on, the output is high at this point, and then as long as this value is still low, is less than off to on to off, the output is still high. As long as immediately is greater than on to off, the value becomes bigger and the output sets. In the same sequence again, when the value now becomes less, not greater than on to off, it again light is still on. So these are logics you need to check. Every PLC program manufacturer comes with a different logic. And it's up to you as the PLC programmer to understand the logics, go through the manual the same way I'm doing. Siemens have their own logics. The logic are the same, but the function blocks are different, very different. Yeah, the structure may be the same, but the functionality, how they operate, you need to read the manuals and understand them very well, so that you don't mess yourself up and start mixing up yourself. Try touch this block, it's not working. You think these things are not working on it. It's up to you to try and reason out well. So I want off to on to off. This value I want to set it. This value I want to pick it. First, you have the value to compare. I want to compare this value by the time the current value set here. So this current value is what I'm comparing with. This one. And then this value is only active when this block is active. So when this block is active, this block is active. This is when the timer is on. Now, I want a value that will be able to trigger when maybe I want this time to come on. I want to capture the value of this timer to be on, so that I'm capturing it on the fly. And the value just reaches there, I get it. And the value I'm going to set, I'm going to use two parameters. I'm going to include an value, and I'm going to name. I want the first value here. I put another number here. So I say this value is this one. That when this value is off to on, the off to on value gets maybe to around 8, 7. when the value is lower than 5, I switch off. So this is the value here we put here is 5. Check. When this value is the value I'm timing is less than this, I put this on. When it's greater than this set value, from off to on, is this trigger, this whole logic changes from on to off. I want to capture this value. So this is we've set it at 7. So when the value gets to 7, it goes on. Okay. Otherwise, value is less. And let's go. Now we are going to do the simulation and check the results are. This is PLC is input. So let's try and see. We want that when it gets to 7, see the two bulbs are now on at the same time, and then when it's off, so this guy is still on. Okay, but amber is still on, red is still on, and it's still on because this guy was still on, red was still on. 7 was on. So we still have an issue. Okay, and that issue we're going to correct because this one is still on, and the reason why it's still on because this logic has not been reset. Okay, still on because the value is greater than 7. That means it's reading 7, 10. Okay, so we are going to stop and edit this logic. So we are going to create another logic. The two outputs that remain are coming on at value on 7, which I've set here. This one. But for the value to become off, this value should be less. Okay. This value, the value should be less than 5. Okay, let's try if maybe sometimes you think, so this value has to be, even if you turn to 10, it will still be on. And 10 value is 10. So let's try and see. Do not change anything. Okay. So simulation. Oh, I need to start this guy. Sorry. So let's see. So you see, not correct. So we stop simulation and we return the value to 5. It only has to be off when the value is 5, less than 5. So we want to edit that. When the value is 10, throw a pulse, and that pulse should be able to activate instead of activating this one, I activate it when the value is 10. When the value is 10, I'm going to activate the circuit. Activate the circuit. And because I know this input of ours is dependent on this block, so now How many guys are still active?
Yes.
Okay,
Yes.
sorry, I lost connectivity. Sorry about that. So let me just share my screen. So just do a quick wrap up because I think we were almost done with the apologies. And so this is where we are. We were doing a simulation of this, and we were able to want to find out if the logic works. So we need to start a PLC and check. So it came on at that time, then remained on. Okay. And now it went off. But we still have, so check, we are debugging this program. This is still active, okay, because the value is still 10. Okay. So how do you be able to counter that? So what you can do here, that you can be able to send a pulse. Okay. Immediately this value is done, you send a pulse to this block, and then it's able to deactivate this value. Okay. So let's see what I mean by that. I want to reset this timer. I can either reset it through here, this only, either through here or through here, so that when this timer is out, okay, so let's join again. So that when this timer is done, that means the value is 10. I see here, and this pulse should be able to activate a pulse output to reset this count. So I'm going to use an OR gate, this one, to be able to 1. It's gone. So 1 to be able to have this value here. You can reset that value with this one, or we reset the value using this output. So we remove this output here and connect it here, and this output we take it here. But we just be able to learn it. So you want this, either this one to reset the main setting block, or this value here should be able to reset this main timer and make its value 0, and then once it's 0, this other value is off. So now what we want here is another block we reset. Now we can now have even this block, can now reset the entire block using this one. This becomes now like our main set, this one. Okay, so yeah. And let's situation. See, the circuit is becoming a bit complex. Anytime you advance, that's why you need to save as version so that you can be able to understand what what's happening. Okay, so we need to run the PLC and let's see. Yeah, you've seen a bug somewhere. Analysis, it goes to the whole signal. And now what's happening is cover 7. Okay, so the reason this is still on is because this is on. Okay, what you can do that we are waiting. Okay, so this trigger value is what we're interested in. This one is what we're interested in. And under this value, as long as this value is on, has been set, it activates the circuit. And when the value is off, the output of the system is off to disable the value. Okay, so that you put an AND gate here, you take the output, the input of this circuit, take an AND, you take an AND gate, okay, and you put it here. So to edit this circuit, and you take an AND gate, you put it here, so that when this value is on and this trigger value is on, we activate this one. This is when you get the on, and we know that this one is on, the gate is active to enable it. So we run again the simulation, see what happens. Start. So have you seen what's happened? Just stop. Run again. Check what's happening. Start again until value number 7. The 2 should come on. 7. So they haven't passed that threshold. So I need to find out why they haven't passed that threshold. So you stop again. Check the bug. Start again. Careful. So this one is still on, but it can't go on because of this other one. So this is the only logic remaining, this initiating this transition from here to here. that one I think will work together. But because of time, I will share this program so that you guys can do an assessment. You can be able to edit it, and then if any one of you comes to the solution, we'll be able to review it, as well as I'll be able to come up with a solution for a way to be able to interact, to play around with this one. So I'm going to stop the simulation, and I'm going to give you this is, I need to edit this value. This is amber on. I want to write something. Amber on. Amber plus red. Very important PLC. So that next time you don't forget. This is now to activate. This is red on. Just make comments so that you're able to know what's happening here. Red on. So that you guys can also to go and understand what's happening here. So this and is, of course, it's for green. You just check the logics here, and then this one is for the amber on. Comments, I'm going to give you the comments, amber. Okay, so this one have the comments. Then this one is amber. So here we need to now to amber plus red off stroke on control. So this is where you need to focus on. Okay, so this is what will guide you. So just pop up, and we've said this one is for same thing like this one. Okay, amber on or off control. I put this one here. Okay, can hide and you can hide. So think up to there. I can save this program as save as. Save it as these 0 programs. This is a traffic light. Sequence. So it's saved, and I think after there we've come to the end of our week run. We will be able to do more interactive sessions as we go, maybe over the weekends when I find time. We can also schedule for a meeting, and we can also be able to tackle more difficult questions. So up to that point, in the interim, let me just share this program on chat on the WhatsApp. Just now. In the interim, you can be making closing remarks, how you find the session, how it was, and then from there we can close the meeting. Any further comments? So how was the program? Was it complex? Was it difficult? How did you find the program? Hello?
Hello,
Yes,
it was
since no one
okay.
is there, I think. Okay.
Hello?
Where are the guys? Yes.
Yeah, it was okay, and thank you.
Yeah, you're welcome. So now you've seen it's not an easy task. Yeah, you really have to write the logics and do your computations on the head for you to be in a better position to tackle the challenges like what you've had. So
Yeah.
I've already uploaded the program. You can take the program and be able to modify it to your own use and try and come up with that logic. You see, you have to make your program organized.
Yeah.
You
Yeah.
actually need to, your program has to be organized. You need to make it a particular format. You edit, you label your comments so that if anything happens to you and somebody else picks over your program, it needs to be easier for him to understand what happens. So these are the sequences you see. I've named all of them and whatever. Then you have, it's flowing. It's actually flowing, and you can know what's happening here, and what's happening there.
Yeah.
If it could be a ladder PLC program, it could be very big, very big. You can imagine how many runs you could be doing, like 1, 2, all these are ranks. There could be like maybe even 30 or 40 ranks. So you can see all these lines crisscrossing and whatever. It could be very complex. Yeah, so sometimes that's why you prefer the FPGA.
Okay.
Right. So any other comments?
Hello.
Yes.
When you started, and then almost 20 minutes in, your audio was not very good. So we followed when you were drawing the AND gates and the trigger, but the explanation, and we missed a lot in your explanation.
Oh no, you should have told me. Did you text on the chat? I
Yes,
didn't
we
see that.
texted you.
Oh, really?
So
I missed that. So, let's see the chat section. The chats. I think this is when I came back. I think the message went out. Yeah.
yeah, but probably at around 5:40. But okay, my point is, if you can if you can just do a summary of all these, then you set it to us on the WhatsApp, because no time may end up here.
Yeah, I've already sent the program
Oh, okay.
on WhatsApp. So,
Yeah, I
and
can
I've
see it.
tried to, as much as possible, to highlight this, to name these blocks and what they mean. And if anyone of you has a challenge, you can always ask. Say you not understand this one or something, then we can be able to explain it in depth.
Okay, thank you.
Okay, you're welcome. So otherwise, guys, thank you for your nice feedback. Thanks for your attendance. I know it was not an easy task. It was not an easy don't say per se. It was really complex, but at least you guys, if you can get something, this is how a PLC program may look like, and this is what happens in the field. So in the field, there are complex programs. This is just a simple that I just select. But you see, you need to think, you need to write the logics, you need to understand what's happening in there. So there's a lot of thinking you need to do. So for you to, if you want to go into the automation and control, you really need to be smart, and you need to think fast and make logics. You need to analyze logic circuits and be able to make a decision where am I going to modify it, what comes here, what comes before this. Yeah. So and then you do bitwise progress. You save, test, simulate, until when you get the final output. From there, you'll be in a better position to actually understand it, troubleshoot your circuit well. Otherwise, thank you for attending, and have a time. Let's plan for another time when you guys, somebody will have finished with the resetting. But I want you to go and run run this simulation, understand it as easy as possible, understand it well, sit down, analyze it, how I was doing it. If you understand it, then you can be able to ask questions, you can do modifications, and now you can start also doing the other assignments that I gave you. I'll share the book. As I get your email accounts, I'll share it on the email accounts. You guys can now be able to go and create those programs. And once you create the programs, you'll be able to share with me, and we'll be able to set a session where you can be able to review. I think that would be best. So that's all for me. Otherwise, thank you so much. If anyone has anything to say, you can say. Guys, we can close the meeting.
Well, thank you for your time also, and for the sacrifice. Yeah.
Okay.
Just hope you will be available if we have questions.
Yeah, I will just create time for you guys, and yeah, we'll still interact. We'll chat. Keep the other guys active. Keep the group active. Yeah, we need to see
Okay,
more guys and more young guys doing this.
So
All right, Francesa, have a nice evening. Thank you so much. That is the program shared. I will share the notes on the email, and have a nice evening. Good time, guys. Goodbye.
you too.
All right.